So here's a little project I've been meaning to do for a while. I thought it might not be a bad idea for me to have a radiation counter of some sort. I found a little do-it-yourself kit on eBay, which I thought I'd have a look at. And so here's what comes in the box. So there's all the components and the circuit board. This must be the tube, and here is a little small display. So zero documentation except some circuit diagrams and stuff, a URL to a website, so maybe there's more information there on assembling the board. Well, a quick look on that website fortunately saves the day. There is a pretty comprehensive step-by-step set of instructions here, complete with kitting list and everything else. Had I taken the time to read the website more closely, I probably wouldn't have bought this kit, because there are a number of surface mount components to be soldered, and thus far, like for instance, you have this how the micro SD card solders onto the board here, and you can see various SMD devices. I've kind of avoided SMD like the plague up to now, so, but hey, it's only a limited number, and so we will give it a shot. I'm going to go away and read a lot of this stuff to make sure I'm familiar, that I have all the bits and pieces, and then come back to it. So here is the main board put together. I didn't think there was any point in me showing you guys me soldering components on the board, because this is all through all the stuff. So apart from it being fairly compact in places, there's no major trauma. This is the board, it's all surface mount, and these are the bits that have to go on there. So there we go, we have a couple of little tiny transistors, we have a voltage regulator, we have two ICs, we have some capacitors and some resistors. We have a memory card slot, a little crystal, and an enormous electrolytic capacitor. So, the chances of me not dropping one of these things and have it vanish forever, I would say are fairly remote. Yeah, we'll give it a shot. This may be my first and last adventure into SMD. We shall see. Just gotta bite the bullet and start have a go at this. I don't think there's any way I can show you me having a go at this, because there's just no room. So I'm gonna have a go at a couple of these, and then if it looks halfway decent, I'll show you the results. Well, I'll show you the results either way. Good or bad. Fortunately, I think the guy has included more than the requisite number of devices, so I presume he's allowed for the fact that you're probably gonna mess up a few or drop a few. Okay, so here is my first attempt at putting together SMD components on the board. I make no pretense for prettiness or or anything. If it works, I'll be happy. I haven't cleaned the flux off yet, mainly because when I did it on the main board, just with some simple IPA, it ate into the solder mask, and so the solder mask all became sticky and gooey. So I'm really reluctant to do it again. I'll have to find something that hopefully will work without attacking the solder mask. Anyway, there we go. So that's kind of the construction complete, except for the buzzer, which goes on the back here. But it says the buzzer can get damaged by any sort of cleaning chemical, so it says clean the circuit board and get rid of all the flux and everything before you solder the buzzer on, and do that right at the end. I guess my comment is it wasn't maybe as difficult as I thought it might have been, but it takes forever. This took me forever. And so can't exactly say it's fun, but with practice I guess I could get better at it. So this is just a bit of a dry mock-up while I'm waiting for the bits and pieces. So this is eventually what it will look like when it's all bolted up together. DC 5 volts comes in here. What I'll probably end up doing, assuming this all works okay, is make a case for it. And from here I'll go to like a barrel connector so I can plug in an external power supply to it to give it the 5 volts. Here we have an on-off switch, which in the drawing is a right angle switch with the toggle pointing out to the side, which of course would be nice for mounting it in a oops, sorry you can't see it. So the on-off switch is here, and so of course if I put it in a box, that's going to be hard to get at. However, I noticed that in the kit there's a switch left over, which is a panel mounting one. So I presume the intent is, if I do put this in a box, then I'll just remove that switch and run some wires to this one, and this one will fit to the side of the box. So that's my assumption anyway. There's 2 little push button switches here, the purpose of which will become known in due course. There's a couple of connectors down here, so this 3-pin connector here is to allow the connection of a GPS module, so that you can, as you're logging the counts, you can also log where you are. I don't have any need for that. And then there's a connector here which is just like a ground and 5 volts, so I presume that would supply the external device if I hook it up. Well, gotta hand it to my local supplier. I ordered up a whole bunch of fuse holders yesterday, and the postman stuck them in the mailbox this morning. So I can't ask for anything better than that. So it turns out that this is just the right size for the detector tube. And so I'm going to use up 2 of them. So I'll cut one end off each. And then I will have the means by which I can hook this thing up. And not only that, if I cut right off at one end and keep the hole, I'll be able to mount these on something solid for later on, and that'll be also good. There we go. I think that's going to work out just fine. Well, it looks like I won't be able to do any testing for a little while, because on further reading of the manual, one has to load software onto the ArtMega, and to do that I need to connect this to a PC, and to connect it to a PC I need something called a USB to TTL interface, which is a little board that'll do all the signal conversion from a USB to a standard TTL 5 volt. Couldn't get one of those locally, so it's an eBay purchase and I have to wait till it shows up. This is a little USB interface gadget I need to get. One is on order. And well, after a considerable delay, here is said USB to TTL adapter. I initially ordered a couple of these guys because they were like $1 each or something from a seller on AliExpress. That was back in early May. We're now early September. Never heard any information. I think it was about 3 weeks after I ordered it, the tracking information said it had now left China. Since then, nothing. I've tried calling the guy, writing, messaging the seller, nothing. And so after a couple of weeks, I ordered a different one, this time off eBay, and sure enough, this one came in a couple of weeks. And so yeah, my first really bad experience, I think, with buying stuff from China. Anyway, so there then followed a little saga about programming, which I'll try not to get down the rat hole too much. But the bottom line is, I think somewhere along the way, I corrupted the software in my AtMega processor in here, and so nothing worked. It was just like a bricked. So to try and remove the variables out of the equation, since I had no idea if this was working properly, I got a standard Arduino Uno, ta-da, like this guy, which is exactly the same microcontroller, and I knew this one worked. And so I programmed the code for the Geiger counter into the controller in the Uno, and then I swapped it over into the Geiger counter itself. And we seem to be in business. Of course, the other complication along the way is the power supply died and went funny, and I had a little delay with fixing that. So all in all, from the moment I finished the construction of this to the point where I got the software installed and the thing actually works, has been maybe 2.5 months elapsed. So, but at least now it looks like we're in business. The logging output on the SD card, just to quickly show you, there are 2 files: a text file, which again is every minute or something it logs the information, and the CSV file, a comma separated value file, which of course you can pop into a spreadsheet and make graphs and all that sort of thing. So I will be playing around with that a little bit later as well. But yeah, so this is an interesting project, and once I've calibrated it and everything else and we're all good, I then have to design some sort of an enclosure to put it in, and come up with a suitable battery replacement power supply, because it draws very little, less than 20 milliamps, and so we're gonna rig up some batteries to it, and then it'll be completely self-contained. So yes, that's the end state.